So as you see here, it says, but what about angles? You know, here's where we are. Here's what we know. We can calculate the value of any of the 6 trigonometric functions, sine, cosine, tangent, cotangent, secant, cosecant, based on some number t and the associated trigonometric point that goes with t along the unit circle. For instance, the little diagram I've got over here, this is a unit circle. Okay, just as a real quick summary, this is a unit circle, which means the radius is 1, doesn't it? So down here is -1 on the y-axis, here's +1 on the x-axis, here's -1 on the x-axis, here's +1 on the y-axis. And we have some number t, and we measure along this unit circle starting from the point 1, 0 right here, t units. And it leaves us at this point on the unit circle that I've labeled P, who has coordinates A and B. So the sine of t is that second coordinate, B. Okay, and we know all of those. What's that got to do with angles? Well, you see there's an angle theta that, I don't know that you can see that clearly, but there's an angle theta that is associated with that real number t when we measure along the unit circle. Here is the deal. Remember that if we measure an angle theta in radians, then the way that angle is measured is that we look at the arc length. See, we've got an angle. We're going backwards this time. We've got an angle, and that angle cuts off a place on the circle, in this case a unit circle. And if we measure the distance from this point 1, 0, where we started a while ago, to that place the angle intersects on the unit circle, that's the arc length, okay? And then we divide by what? The radius of the circle, don't we? Radius of the circle. Well, in this case, of course, when we look at this angle theta measured in radians, the arc length is this number t that we've been talking about. Okay, we started with t and measured off an angle, but if we've got an angle, we can measure off the t. Now, in our case, the radius, because this is a unit circle, we've got a unit circle. Well, a unit circle is one that has a radius of 1. So our radius is actually 1. Oh, so the measure in radians of this angle theta is just the number t. So they're more or less the same thing. More or less the same thing. So our job becomes this. If we want to know the sine of an angle, we've got to know the position that angle gives us on the unit circle. That's what it all boils down to. We've got to know the position of that angle. So we're not worried about t so much, we're worried about an angle since they're the same. That's the really big issue. Here's what we've got. In the above example, the sine of t, is the same as the sine of theta, the angle theta, measured in radians. Measured in radians. And I really should be going the other way. If we want to know the sine of an angle measured in radians, we just need to figure out the point that's associated with theta or t. In other words, this number t is the same as theta. That becomes our job. We've got to figure out for a bunch of angles what these trigonometric points are. So let me kind of summarize this way to begin with. What is P? What is this point when theta is equal to pi over 4 radians? And see, remember, that's just the same value. Theta is really what t is. So the question is, here's the question. Let's stop and look at this. Here's what this question really is. Let me make a little bigger unit circle, so well, maybe not. let's see, and don't laugh at my circles here. This is a bigger unit circle, so I can deal with it, and obviously it's not very pretty, and I guess I'm going to have to relabel this. This is where 1 is. So this point, okay, this point, because this is the x-axis and that's 1, this point has an x value of 1 and a y value of 0. Okay, now this point has a x value of 0 and a y value of 1. This point, because this is a unit circle, this point has an x value of -1 and a y value of 0, and this point has an x value of 0 and a y value of -1. Now, what about theta equal pi over 4 radians? Well, remember this. That's the same thing as 45-degree angle, isn't it? So if we measured a 45-degree angle, or pi over 4, okay, so pi over 4, so that's this angle right here, we'll say. That's where theta is equal to pi over 4, which could also be, if we were thinking about in degrees, 45 degrees. So it's this distance right here, this is the arc length, that distance is also pi over 4. So the angle and the arc length on a unit circle, angle measured in radians, same thing. But our job is, what are the coordinates of this point? See, what are the coordinates of that particular point if we have an angle of pi over 4? Well, how could we figure that out? How could we figure that out? Think about it for a second. Oh, by the way, this is a unit circle, so this distance of this initial side is 1 unit, and the distance of this terminal side is also 1 unit, isn't it? Now, let me take this. Let's do this. Let's come along here, and let's connect these 2 points. So we've actually got a triangle there, don't we? And we've got a triangle. Well, I've had a second thought here. Ignore that line that I drew. I apologize. Let's think about this point. See, pi over 4 is the angle pi over 4, 45 degrees. On this angle, the x and y values are the same. I mean, you can see that if we measure from here to here, it's going to be the same as we measure from here to here. And if that's the case, the x and y values have to be the same. Pardon me. So if our point, remember, that we're talking about, has the coordinates A and B, A has to be equal to B if we're talking about pi over 4 angle. If this is our pi over 4 angle, which is the same as 45 degrees that we've already been talking about here. Well, if that's the case, okay, if that's the case, remember, we're on a unit circle. Don't forget that. We're on a unit circle, and the equation of a unit circle is x squared plus y squared is equal to 1. Now remember, A is the x value and B is the y value. So normally, in this case, what would have to be true for this point would be that a squared plus b squared is equal to 1. Now in this particular case, when our angle is pi over 4, when that radian measures pi over 4, or 45 degrees, then we know the a and b are the same. So why don't we replace, that is, the b with the same value that is a. I'm just replacing b with a since they're the same. So we end up with 2 of these a squareds is equal to 1. Well, that means a squared is equal to 1/2. Oh, now remember, we're in this first quadrant, and so a is a positive number. So a, if a squared is 1/2, a would have to be the positive square root of 1/2. And of course, that we could write as the square root of 1 divided by the square root of 2. And of course, the square root of 1 is simply 1. So we have a is 1 over the square, a is 1 over the square root of 2. Well, if we rationalize, and we need to rationalize, remember we multiply the denominator by the square root of 2, which would mean we'd have to multiply the numerator by the square root of 2. And so the result that we would get here is that a is the square root of 2 for the numerator. Square root of 2 times square root of 2 is just 2. So the a that we have is the square root of 2 over 2. And remember, that's the same as b. So this trigonometric point, okay, when theta is pi over 4, remembering that that's the same thing as 45 degrees, then the trig point, I'm not going to say the trig point, trigonometric point, but then the point on the unit circle is the a value, the x value square root of 2 over 2, and the y value, which is b, is also the square root of 2 over 2. That is a big deal. So now we can find the sine of pi over 4. We can find the cosine of pi over 4. We can find all of the 6 trig functions. Let's go through that. Well, in summary, what we're doing here, the directions may not be real clear. Now that we know the trig point, see, the point on the unit circle for pi over 4 is square root of 2, comma, over 2, comma, square root of 2 over 2. Okay. And so we're to find the sine of pi over 4, the cosine of pi over 4, and so on. Okay, now, just again, I need you to get this into your head because we use this idea over and over and over. If we have an angle that's pi over 4, same as 45 degrees, then it brings us right here. Okay? So I'm thinking of that as the angle pi over 4 rather than writing it down here. Okay? Now that point, that's the important part, that point on the unit circle has the coordinates square root of 2 over 2, comma, square root of 2 over 2. And that was based on being on the unit circle, wasn't it? Okay. Well, now we can calculate. Then the sine of, instead of calling it t now, because it's the same t, and that is the arc length, and the angle in radian measure are the same because we discovered that a while ago. Okay. Because we're on a unit circle. Well, how do we calculate the sine of this number? We look at the, on the unit circle, we look at the second coordinate of the point that it brings us to. So we're looking at the second coordinate of that point where the angle intersects the unit circle. And that second coordinate is the square root of 2 over 2, isn't it? Okay, so no problem. Well, now that also means that if we were asked to calculate the sine of 45 degrees, because pi over 4 and 45 degrees are the same angle, just one in radian measure and one in degree measure, we would also have the square root of 2 over 2. Okay? Someone asked us to calculate the cosine of pi over 4. Well, what would we do? We would go to our unit circle. For the angle pi over 4, we would look at the point that intersects, the angle intersects with the unit circle. Remember, the angle we're talking about has an initial side on the positive x-axis, and the terminal side is going to intersect the unit circle somewhere. We look at that point, we've got it above, and the cosine then of that angle would be the first coordinate rather than the second coordinate. Well, the first coordinate happens to be the square root of 2 over 2. So likewise, the cosine of 45 degrees is the square root of 2 over 2. Well, let's turn our attention to tangent. the tangent of pi over 4. The tangent of pi over 4. Well, we have to have this memorized. Remember, it was the second coordinate, okay, divided by the first coordinate. That's what the tangent of pi over 4 is, of the particular point. Well, in this case, the second coordinate is the square root of 2 over 2. The first coordinate is the square root of 2 over 2. And so when we do that division, we get 1, don't we? So that same idea would tell us that the tangent of 45 degrees, since 45 degrees and pi over 4 are the same, tangent of 45 degrees is 1. Now, we want to know the cotangent of pi over 4. Well, from what we talked about before, the cotangent of pi over 4 is the first coordinate of the point divided by the second coordinate of the point. Well, in this case, the first, and maybe I ought to say, so I hate to confuse us with how we're labeling these points, but at that point, we could think about, oh, this is the x value and this is the y value, but couldn't we? So we could say it's the x value divided by the y value. That would work just fine. Well, in this case, the x value of that point is the square root of 2 over 2, and the y value of that point is the square root of 2 over 2. So, of course, that's a 1 again. And likewise, that would tell us that the cotangent of 45 degrees is also 1. Well, what about the secant of pi over 4? So we got a lot of things going on here. First, we got to remember, oh, how do we calculate secant? Let's see, how do we calculate secant? Well, wasn't secant 1 over the second coordinate? 1 over the second coordinate. Well, in this case, 1 over the second coordinate, let's see. What is that second coordinate? Or we could say just 1 over the second coordinate and thinking of it as y. Oh, well, that would be 1 over the second coordinate is the square root of 2 over 2. Now, we've got a little bit of work here, so let's step below here. Now that we've kind of decided what it is, and let me just rewrite it, 1 over the square root of 2 over 2. But when we divide by a fraction, that's the same thing as multiplying by the reciprocal, isn't it? So we'll write this as 1 times 2 over the square root of 2. Well, of course, that is just 2 over the square root of 2. And 2 over the square root of 2, we should rationalize. And so we'll multiply the denominator by the square root of 2, which requires us to multiply the numerator by the square root of 2. So now the numerator is 2 times the square root of 2, and when we multiply the denominators together, we get a 2. And you see we have a convenient deal here that those 2's cancel, and so we simply get the square root of 2. Well, what about then, the last one we've got is the cosecant of pi over 4. Oh, remember then that the secant of 45 degrees is also just the square root of 2, just the square root of 2. Okay, the cosecant of pi over 4 is really going to be a duplication of what we just did, because the cosecant is 1 over the second coordinate. I apologize to you. I did secant all wrong. The secant is 1 over the first coordinate. Oh, my goodness. Oh, my goodness. The secant's 1 over the first coordinate. Oh, well, we're kind of fortunate here that the first coordinate is the same as the second coordinate, isn't it? The cosecant is 1 over the second coordinate. And 1 over the second coordinate is 1 over the square root of 2 over 2. And we've just been through all of this, haven't we? And we discovered that that ended up being the square root of 2. So the cosecant and the secant are the same. Well, they kind of match all the way down in this case, don't they? So the cosecant of 45 degrees is the square root of 2. Now, before we move on to a different special angle, there's actually, well, let me pause here and we'll go to the next page and do a little bit of summary of what we just did. So, and and kind of tell you where we're headed. Okay, I want to do that. There's going to be a lot of information in trigonometry. There is a lot of information that we have a tendency to think we need to memorize everything. And there's a lot we do have to memorize. There's an awful lot that we have to memorize, but we can't memorize everything. And so we have to have a way of putting things together. So let me tell you first that there's a bunch of special angles, and I'm going to talk about special angles and we'll come right back to what we were just doing, but special angles, and first I'm thinking in terms of radian measure, okay? And so the special angle 0 in radian measure is, of course, 0 degrees. That's the same as 0 degrees in degree measure, okay? So the left is radian measure, the right is degree measure. Maybe I should put that here. Radian, degree. Now there's another special angle, pi over 6. Okay, pi over 6. That's a special angle. We use it all of the time. Now, if you recall, that's the same thing as 30 degrees. There's another special angle. Let me come over here, and that's pi over 4. And as we just talked about, that's the same thing as 45 degrees, okay? And there's another special angle, and that's pi over 3. And from our previous work, we found out that that's the same as 60 degrees. And there's another special angle, pi over 2. Pardon me. And we discovered that's the same as 90 degrees. Now, and I suppose there's another special angle that's 2 pi, and that's the same as 360 degrees. I mean, there's a lot of other special angles. I had to clear my throat. So let me list these, though. I'm thinking of 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Those are all either, they're not all in the first quadrant, okay, but they all live, if we're thinking of the unit circle, they all live in here, okay? They all live in here. Now, because the fact that we're thinking of circles here, and the circle is symmetric across the x-axis and across the y-axis, if we can learn about the angles that are in the first quadrant, we can extend that later on to learn about angles that are in the fourth quadrant, or the second quadrant, or the third quadrant. So it's very important that we learn about the angles in the first quadrant. So the angle 0, pi over 6, pi over 4, pi over 3, and pi over 2 become very critical to learn everything we can about them. Very critical. Now, here's the next piece that we need to put together. I have a hard time, maybe you don't. I have a hard time, so remember, here's what we said. If we have a point on the unit circle, so if we have a point that is on the unit circle, doesn't matter where it is, but let's talk about these angles that put us here, okay? So if we have a point on the unit circle, and that point has the coordinates x comma y, okay? And we got there by measuring t units along this way, but that t units is the same as the angle theta in radians. So here's the way we define this. The sine of theta, I'm doing sine first. I think I started with cosine before, but the sine of that angle theta is the second coordinate of that point. So it's the y value. And we said then that, let's do this, the cosine of theta then is the first point. And then when we talked about tangent, okay, when we talked about tangent of that angle theta or t, then we said, oh, that is the second coordinate divided by the first coordinate. Now that's kind of, yeah, we can go back over there and look, but remember that that's the same thing as the sine of theta, that's the second coordinate, divided by the cosine of theta. So what I'm getting at here is once we know these two, we can use those to calculate the tangent of theta. Now, what about the cotangent of theta? Well, we were told that the cotangent of theta is the first coordinate of that point divided by the second. Well, the first coordinate is also cosine of theta, and the second coordinate is the sine of theta. So if we know those two, we can calculate the cotangent of theta by remembering that, and the tangent of theta by remembering that. Now, what about the secant of theta? Okay, well, the secant of theta, we said was 1 over the first coordinate. Well, since the first coordinate is the same, cosine of theta is the first coordinate, that's 1 over the cosine of theta. So once we know the cosine of theta, we can calculate the secant of theta if we remember this. And likewise with the cosecant of theta. Cosecant of theta, we were told, is 1 over by definition, is 1 over the second coordinate. Well, the second coordinate is also the sine of theta. So once we know the sine of theta, if we remember that the cosecant of theta is 1 over the sine of theta, then we can easily calculate it. And so here's what I would have remembered. See, here's what I would remember. That the sine of pi over 4, which is the same as the sine of 45 degrees, is the square root of 2 over 2. That's critical. And I'd also remember that the cosine of pi over 4, which is also the cosine of 45 degrees, that's also the square root of 2 over 2. I need to remember that. Okay, now here's what else I need to remember. So also, for instance, I need to remember that the tangent of theta is the sine of theta divided by the cosine of theta. Now, if I remember that, then I can say, oh, see, if I remember that as, oh, someone wants me to calculate the tangent of pi over 4. So what do? I remember that this is how I calculate tangent, so that's going to be the sine of pi over 4 divided by the cosine of pi over 4. And the sine of pi over 4 I've memorized, it's the square root of 2 over 2. And the cosine of pi over 4 I've memorized, it's the square root of 2 over 2. And so I get a value of 1. So that's the process that I need to go through. It's remembering the formula for the tangent of theta in terms of sine and cosine. And remembering the tangent of cotangent, the formula for cotangent in terms of sine and cosine and all the way down, rather than in terms of the point on the unit circle. Okay, let's next look at here. Pi over 4 is the first special angle that we picked out, but let's kind of extend this idea for a moment and look at some other special angles. We'll start with well, I tell you what, let's go to the special angle pi over 6, and actually pi over 6 and pi over 3 are pretty closely related, so we'll do that on the next page. So we're going to kind of simultaneously consider the two angles pi over 6 and pi over 3. This is kind of sloppy 3 I see there. Okay. Now we're going to look at the unit circle so that we kind of get our bearings. Okay, and play like that's a unit circle. I apologize here. Okay, so I'm exaggerating, but let's suppose this is a 60-degree angle. Okay, This is the 60-degree angle. So it's pi over 3 that we're talking about here, of course, which is 60 degrees. So this is that angle. Now, let's take this position on the unit circle, because what we really want to know are those points, aren't we? So we want to know that point, pardon me. We want to know that point, so that means we need to know its x value and its y value. Okay, so let's drop a vertical right here. Now, let me come to this position, and let me just draw that triangle right there. Okay, so this is that same triangle, but I've expanded it, of course. Now, remember, this is that 60-degree angle. And this is a 90-degree angle, a right angle, okay, because I dropped it as a vertical. And remember, the angles of a right triangle, angles of any triangle add up to 180 degrees. And so this angle right here is 30 degrees. So this one triangle has both 60 degrees in it and 30 degrees in it, okay? Well, now, what do we know? Well, we know that this side of this right triangle is 1. Because remember, that's this position from the center of the circle to the edge of the circle, and this is a unit circle. The unit circle, of course, has a radius of 1. So this distance right there is 1. Okay, now let's do this next. Let's flip this triangle so that we have a mirror image of it over here. Okay? Now we flip the triangle. So this is 60 degrees, and these two together, a 30 degrees and a 30 degrees, this is 60 degrees. So now we have a triangle where all sides are the same length. Okay? All angles are the same, so all sides are the same length. Well, we already knew this was 1. And so this entire side has to be a length of 1, because all angles are the same. This is an equilateral triangle, isn't it? Well, if the entire side base there with those two triangles together is 1, then this part of that triangle is 1/2. Now, let's come back and let me go back to this original triangle that we had, okay? So now we know, remember this is 60 degrees right here. We know that this is 1 and this is 1/2, and this is a right triangle. Well, in a right triangle, what do we have? A squared plus b squared has to equal to c squared, where a and b are the legs and c is the hypotenuse. So this would be the c value. We could say this is the a value. What is the b value? Well, according to the Pythagorean Theorem, we would have a squared, which is 1/2 squared, plus b squared is equal to c squared, and c is 1, so that would be 1 squared. Well, when we square 1/2, we get 1/2 times 1/2. And of course, 1/2 times 1/2 is 1 times 1 divided by 2 times 2, as a quick reminder. I'm probably not going to do that in the future, but that's a 1/4. So we have a 1/4 here. Plus b squared is equal to 1. So let's subtract, we want to know the value of b. So b squared would be subtract 1/4 from both sides. 1 subtract 1/4. Well, when we take 1 and subtract 1/4, we get 3/4. So b, now, b is the length of a triangle, and so it can't be negative. So b squared, in this case, usually would say it's plus or minus the square root. B would be plus or minus the square root, since b squared is 3/4, but we know b has to be positive. So b is the positive square root of 3/4. Well, that's the square root of 3 divided by the square root of 4. And of course, the square root of 4 we can simplify to 2. So this side, b, is the square root of 3 divided by 2. My bad. Okay, that's that value. Well, what in the world does that have to do with what we've been working on? Okay, here's what it has to do. Let's go back to this unit circle. Let me make the unit circle a little larger. Okay, a little larger. Just so we can see it, and apologize for my poor drawing. So here's the 60-degree angle that we were talking about. And we dropped this vertical. We found that this distance right here, this leg, is 1/2. And we found that this side of that triangle is the square root of 3/2. So that tells us what the coordinates of this point are. Because the base of that triangle, where we have the 1/2, that base is the x-coordinate of that point, isn't it? So this point has an x-coordinate of 1/2. And the second coordinate has to do with that vertical distance. See, how high are we along the y-axis? Well, because of that side of the triangle is square root of 3/2, that's the y value. That's the y value of that point. Now, that's dealing with 60 degrees, isn't it? See, that's the 60 degrees. So here's what we know then. Let's kind of summarize this real quickly. The sine, okay, the sine of 60 degrees is the same as pi/3, isn't it? The sine of pi/3, which is the same as the sine of 60 degrees, since those are the same, we just, oh, what is it? It's the second coordinate. Well, the second coordinate is the square root of 3/2. And the cosine of pi/3, well, that's the same as the cosine of 60 degrees. And that's the first coordinate of the point, that's 1/2. So this is what we need to get memorized. Now from that we can calculate the others. Okay, we can calculate the others. Okay, now, where are we? Okay, where are we? We're going to find the exact values of the trig functions of pi/3. Okay, we're going to find the exact values of the trig functions of pi/3. So, for instance, like the cosecant of pi/3, secant of pi/3, the tangent of pi/3, and so on. Okay, but here's the thing to come away with. Again, remember, if you're wanting something to memorize, remember. And yeah, some of this we have to memorize. We just found out. Okay, so let's refer to our unit circle that the sine of pi/3. What did it decide it was? Do you recall? Square root of 3/2, wasn't it? Okay. And remember that the cosine of pi/3 is equal to 1/2. As we're looking at the unit circle, pi/3 is equivalent to 60 degrees, so it's roughly right here. So we're talking about this point, okay? This is where we're talking about pi/3. We're talking about this point. This point has the coordinates. The first coordinate is 1/2. The second coordinate is the square root of 3/2. That's where that information came from. Okay. Now we're going to be asked to calculate or determine, so I'll say calculate exactly, okay, the tangent of pi/3, the cotangent of pi/3, the secant of pi/3, and the cosecant of pi/3. But before we do that, let's remember this. Okay, I'm trying to make a point here. I know it takes a while to do some of this, but I'm trying to make a point. How are we going to do it? Well, this is the other stuff we need to remember, that the tangent of an angle theta Okay, the tangent of an angle theta, we used to say t, but the tangent of angle theta is the sine of that angle divided by the cosine of that angle. Also remember that the cotangent of theta is the cosine of that angle divided by the sine of that angle. Also remember that the secant of theta is 1 over the cosine of that angle. And the cosecant of theta, remember that's 1 over the sine of theta. So if we remember this, and we remember this, then there is no problem to this. No difficulties, okay? So we want to know the tangent of pi over 3. Remember that that's the sine of pi over 3 divided by the cosine of pi over 3. And since we know the sine of pi over 3 is the square root of 3 over 2, and the cosine of pi over 3 is 1/2, then we have a fraction, square root of 3 over 1/2. Now we have to be able to do some algebra to simplify that. So we would take the square root of 3 over 2 and multiply by the divisor, the reciprocal of the divisor. Reciprocal of 1 over 2 is 2 over 1. So we'd get nice cancellation, and we'd get the square root of 3. Now you're not going to memorize the tangent of pi over 3 is the square root of 3. You're going to memorize what the sine of pi over 3 is, cosine of pi over 3, and how we calculate tangent. That's what you memorize. So if we wanted to know the, well, let's say we wanted to know what the, well, let's just do cotangent. Cotangent of pi over 3. Well, what we have to remember is that's the cosine of pi over 3 divided by the sine of pi over 3. And since we are remembering that the cosine of pi over 3 is 1/2, okay, and that the sine of pi over 3 is the square root of 3 over 2, then we have a mode of calculating. Well, in this case, we're going to take 1/2 and multiply by the reciprocal of the divisor, and here the reciprocal of the divisor is 2 over the square root of 3. And you see now we have the 2's cancel, so we end up with 1 over the square root of 3, and then we have to rationalize, okay? So we'll multiply by the square root of 3 over the square root of 3, and when we're finished there, we get the square root of 3 in the numerator, and in the denominator, we end up with just a 3. And we'll do one more. I'm not going to go through each of these each time. Suppose we wanted to know the secant of pi over 3. Well, what we have to remember is the secant of any angle is the same as 1 over the cosine of that same angle. Now, once we remember that, and we also already know that the cosine of pi over 3 is 1/2, this becomes 1 over 1/2. And of course, that's 1 times the reciprocal of 1/2, which is just a 2. And we could continue. So that's the idea. What is it we need to remember so that we can do all the rest of the work? Now, we've got the information for pi over 6. Pi over 3. And I said we were doing pi over 3 and pi over 6. So let's look at pi over 6 at this point. Well, here's the situation with pi over 6. Unit circle. Okay, so that means this point is a point 1 comma 0, right? And this point is a point 0 comma -1, and this point is the point -1 comma 0, and this is the point 0 comma 1. I probably went backwards. I should have gone counterclockwise. Now, pi over 6, which is about 30 degrees, we'll say is along here. Okay, so that's our pi over 6, 30 degrees. But what we need to know are the coordinates of this point. Say, what are the coordinates of that point? And of course, it's got an x value and a y value. What are those? So this is our 30 degrees. Let's drop this vertical, And when we look here now, say let's just expand that triangle. That's all I'm doing is expanding that triangle. Now, this is actually going to be the y value of that point, isn't it? That's the y value. And this is going to actually be the x value of that point. See, on here is that distance x right there. And of course right here is that distance y right there. Okay, and we know that this is 30 degrees here. Well, oh, and this is the x value. Now, if we do kind of like what we did a moment ago, and we just kind of flip this triangle, okay, then, oh, by the way, we know this distance is 1 because that's the radius of the circle, isn't it? And if we flip that like we did a while ago, oh, and by the way, this is 90 degrees, and so this is 60 degrees right here. It's that same triangle, except it's laying down on its side now, isn't it? So this is also 60 degrees, and now we have an angle right here altogether that is 60 degrees. It's 230s, isn't it? So that tells us this side is 1, and this entire side is 1, and y is half of this entire side, so it's 1/2. And then we would have to calculate this x value. We'd have to calculate this distance, but that's just the side of a right triangle. Okay, we know this is 1. This is the unknown side. This is that a side, which is going to actually be our x value, isn't it? And we know that this is 1/2. And so when we go through all that work like we did before, what would we find out? In this case, is using the Pythagorean Theorem, we find out a is the square root of 3/2. And that a value represents the same as that x coordinate, doesn't it? So I've really kind of summarized this more than anything else, but what we're finding out is it's the same process we did with pi over 3 or 60 degrees. It's just in a different orientation. But this time it's the first coordinate, the x value, that ends up being the square root of 3/2. So I mean, when we calculate this, see, when we're trying to find a, we would have the hypotenuse squared is equal to a squared plus b squared, but the b is 1/2 and the c is 1. And so when we go about doing this, just like we did before, okay, that looks like what we solved before, and we would end up with a squared is equal to 3/4. And when we find a, then that would be the square root of 3/4, which is the square root of 3/2. And, you know, it's a little more complete, but I went through it quickly. And then the y value is the 1/2. So let me clean this unit circle up again, okay, because we've got all this big mess, but what we really have here on this unit circle, okay, this is a unit circle, so this is the point 1, 0. This is the point 0, 1, unit circle. And looks like it's got a little bulb there, doesn't it? And this is pi over 6, which is equivalent to 30 degrees, isn't it? Then this point, okay, that's the critical part. This point has a first coordinate that's the square root of 3/2 and a second coordinate that is 1/2. Okay, that point. So here's our 30-degree angle or pi over 6 angle. So now we can conclude, okay, the sine of pi over 6, which is equivalent to the sine of 30 degrees, is the second coordinate of the appropriate point. In this case, that's 1/2. And the cosine of pi over 6, which is equal to the same thing as the cosine of 30 degrees, is the first coordinate. And the first coordinate is the square root of 3/2. So this is the critical part. That's what we remember. So now we can calculate the tangent of pi over 6. And the way we calculate the tangent of pi over 6 is we remember that the tangent function is the sine of the angle, pi over 6, divided by the cosine of the angle, which is pi over 6. And because we know that the sine of the angle is 1/2, and we know the cosine of the angle is the square root of 3/2, then we have our way of completing. Okay, so we would get what, 1/2 times the reciprocal, which would be 2 over the square root of 3, which would be 1 over the square root of 3. Now let's be careful. The tangent of pi over 6 is 1 over the square root of 3, but we need to write that in rationalized form. So we'd multiply the denominator by the square root of 3, which would require the same of the numerator. And we'd get square root of 3 in the numerator, and then the denominator, when we multiply square root of 3 and square root of 3, we get 3. So tangent of pi over 6 is square root of 3, and the others could follow. Others would follow. So for instance, if we wanted to know the cosecant of pi over 6, well, what we'd have to remember is the cosecant is 1 over the sine of the angle. So it'd be 1 over the sine of pi over 6. And since we know the sine of pi over 6 is 1/2, this is 1 over 1/2. And 1 divided by 1/2 is 2, so we can calculate it. So I remembered this, and I remembered this, and along with the sine and cosine values of pi over 6. That's how we do our calculations. Wow, there's already a lot to remember, isn't there? A lot already. Let's stop here for a moment. And so we have information. What have we done so far? We have information about the 3 special angles: pi over 6 now, pi over 4 now, and pi over 3, which are 30 degrees, 45 degrees, and 60 degrees. But remember, I said there were a couple of other special angles, particularly 0 radians or 0 degrees, and also pi over 2 radians, which is the same as 90 degrees. So let's consider those on the next page, and then we'll try to put some pieces together. So one of our angle is 0 radians. This is radians, of course. Remember, we don't see any units. Okay, 0 radians are 0 degrees. Well, think about the unit circle. Oh, I'm sorry, man. I'm getting sloppier and sloppier. Okay, unit circle. Well, remember, on the unit circle, we have a radius of 1. That's down at -1. This is at 1. This is at 1. And this is at -1. Unit circle. Where are we if we're at 0 degrees or 0 radians? We're at this position that I've labeled in there. What are the coordinates of that point? Well, the coordinates of that point, first coordinate is 1, the second coordinate is 0, isn't it? Okay, well now, what is the sine of an angle, in this case theta, at the angle of 0 radians or 0 degrees? What is the sine of that? Well, the sine is the second coordinate at the point we're at. And that point we're at is 1, 0, and the second coordinate is 0. So the sine of 0 is 0. Now, similarly, what's the cosine of 0? Well, for the cosine, we look at the first coordinate, don't we? In this case, the first coordinate is 1. So the cosine of 0 radians or 0 degrees is 1. Now, what would we have here then? Let's consider the tangent of 0. Well, remember, the tangent is the sine of the angle, of the angle, 0 in this case, divided by the cosine of the angle. And since the sine is 0, and the cosine is 1, and 0 over 1 is 0, the tangent of theta is 0. The tangent of 0 is 0. But we do run into some problems. I don't quite have room to do it there. The cotangent of 0, well, remember how we calculate cotangent? It's cosine of the angle divided by sine of the angle. And in this case, the cosine, of course, is 1, but the sine is 0, and that's undefined. So the cotangent of 0 is undefined. And in a similar fashion, if we looked at the secant of 0, well, the secant of 0 is 1 over the cosine of 0. And of course, that's a 1, and so the secant of 0 is 1. Now the cosecant of 0 is 1 over the sine of 0. And since the sine of 0 is 0, this also becomes undefined, or is undefined. Well, what about? What about theta being equal to pi over 2, which would be 90 degrees, wouldn't it? So all we do is we consider the unit circle. Well, 90 degrees or pi over 2 puts us right here, doesn't it? And because this is a unit circle, then that means, well, of course, the x-coordinate is 0 and the y-coordinate is 1, isn't it? So if we considered then here, we wanted to know the sine of pi over 2, or 90 degrees. The sine of pi over 2, which is the same as sine of 90 degrees, that's the second coordinate of the point that we're at. See, here's our angle. There's our angle, right there. And it puts us at this point, doesn't it? Okay. So, sine of pi over 2, second coordinate, we got a 1. Cosine of pi over 2, that's the first coordinate. Oh, that's a 0. Tangent of pi over 2. Well, tangent of pi over 2 is sine of pi over 2 divided by cosine of pi over 2. Or we can just remember second coordinate over first coordinate, and that's all right. That'd be a 1 over 0, and that's undefined, isn't it? And the cotangent of pi over 2, you see what I'm doing. Well, the cotangent would be the cosine of the angle divided by the sine of the angle. Okay? And the cosine of pi over 2 is 0. And the sine of pi over 2 is 1. And 0 divided by 1 is 0. And we could go through the rest of them. I'm not going to... you can generate these on your own. It's, that's not that big a deal. So sometimes we're going to have values that are undefined. Well, what about? Let's just kind of keep on this idea. What about if theta is equal to pi, which is the same as 180 degrees, isn't it? So we'd come in here and we'd say, okay, where is the angle pi, or 180 degrees? Well, that's this angle, isn't it? So where are we on the unit circle? We're right there. What are the coordinates of that point? Well, the first coordinate's -1, the second coordinate's 0. So from there we can say, okay, what's the sine of 180 degrees? 4 pi. Well, that's the second coordinate. That's 0. What's the cosine of pi? Oh, that's the first coordinate. That's -1. What is the secant of pi? Well, what we have to remember is secant is 1 over cosine. So it'd be 1 over the cosine of pi. Pi. And we know that cosine of pi is -1. 1 over -1 is -1. I mean, that's the way we go through this. I mean, we're going to, see, I forgot my question marks. So if we know where we are on the unit circle, then we just have to know the first and second coordinates, which will tell us the value of sine and the value of cosine. Okay? See, if we know the point on the unit circle that we're at, then from there we know the sine and cosine values. And once we know the sine and cosine values, then all the other trig functions fall into place. So we've got to have a way to remember sine and cosine values or coordinates on the unit circle. That becomes critical.